So this question starts off by providing us with this equation, negative x squared plus bx minus 676 equals 0. It goes on to say, in the given equation, b is a positive integer. The equation has no real solution. What is the greatest possible value of b? All right, so here's the hint. No real solution. Well, if it doesn't have a real solution, it means it has an imaginary solution. But how do we even determine what types of solutions? Quadratic equations, because again, this is a quadratic equation that we're dealing with, where a is equal to -1, b is b, and c is equal to negative 676. I'm just putting these in there, actually there, in their places. So what we use is something called a discriminant. So the discriminant tells us that b squared minus 4ac, when that value is less than 0, we expect no real solutions. We also expect 2 imaginary solutions. Right? So those two things are synonymous. So what is the greatest possible value of b? Well, that's why, we have to choose, because we have 2 imaginary solutions for b. So let's see. Well, we don't know what b is. Let me just go over here for some more space. I don't know what b is, but I do know that a is -1 and c is negative 676. And I also know that all of this has to be less than 0. So when I do the math here, I'm going to multiply -4 times 1. -4 times -1, which is positive 4. And then multiply that by 676, or negative 676. And I end up with b squared minus 2,704 is less than 0. So of course I can add 2704 to both sides. So I'd have b squared is less than positive 2704. And then I can take the square root of both sides here. And let's see, I wrote that down wrong. 2704, take the square root. And that is b is less than 52. It really is plus or minus 52. But we want the greatest possible value. So the greatest possible value this can be is actually going to be 51. Because we're told b is a positive integer, right? So it can't be a decimal. It can't be like 51.9. So 51 is the greatest possible value b can equal.